Right, so excuse me if I don't talk much, but I'm trying to remember shit from years ago, from like 20-30 years ago, stuff that I used to build, and I'm trying to remember values that I used to use and stuff like that. So I'm just trying to do it off the top of my head, right? So I can't talk much when I'm doing it, because you just can't talk and think at the same time, you know what I mean? It's just not easy. So this is the section that I'm going to be modifying. I will talk about this bit, but instead of having a sink on the ground, which is I don't like, because the output basically was sinking previously on the BC547. If you look at the previous video, you'll see it. But on the previous video, I was basically sinking the ground. Well, I don't want that. I want a common ground. So that's common ground to this now. So what I'm going to use is another BC556 actually, but this is 557. I'm going to use another one to flip that around, so I can basically source a positive signal to the MOSFET driver board, which is separate, which is what I was showing previously. It's a Chinese board I got. Anyway, so I want to supply a positive signal to that board rather than a sink. I want to have a common ground. I don't want to be messing about with different ground rails and having cross connections where you get a ground and then it doesn't work anymore and all that. So, and I was trying to remember the biasing for the BC109, but yeah, but the BC557 shouldn't be all that different anyway. So I'm using lower values. I'm using a 4.7K between this PMP between base and emitter to basically make sure the transistor's turned off until it's triggered, and we're using just the standard 10K. I figure let's stick with standard values, because these are all using 10Ks anyway. So or 1Ks, whatever. So yeah, I'll change that to a 1. Let's stick with standard values. There's no point in making it, but the BC109 is over here somewhere. I'm going to use that as a soft starter. Let's just clean this up a bit. I want to move that over there so it's giving me a bit more room. So this is the BC109. It says BC109A. Well, I'm using it as a BC109C. It doesn't really matter. Let's get rid of some of this clutter. It's too much text on the screen. Reference name, package name. We don't really need that. Right, what's it got over there? So it's the times when I'm not talking very much is either because I'm in the kitchen making another cup of coffee, or it's because I'm thinking. probably need to make some food because I keep on nibbling. So I'm trying to minimise the trying to minimise the signal interference that we might get from an AC signal. So right, so the soft starter let me just highlight this net. I want to highlight that net because that's the signal that we're going to tap into. I don't want to get my connections crossed. So we're going to use the on trigger pulse to drive both the normal driver circuit and to drive the soft starter, which basically will be when it's basically stationary and we need it to start with a lower voltage from the coil. So we have to bias this BC109 from the actual voltage on the DC side, not the AC side, because the AC side is basically non-existent at this point. So what I'm going to do is I'm going to basically have a resistor and a capacitor network, and the resistor will basically charge the capacitor up, and that capacitor will supply voltage to the BC109's collector, and that voltage will basically be discharged by the main circuit once it starts to function, so that the BC109 can no longer run, because it'll be all running on the main system by that time. So the BC109 will effectively be an intermediary. It will be the negotiator. You know, it will basically be the thing that says, right, we're going to start this thing going, and once it gets it going, then the main system will take over. What the hell? I keep getting these messages. What the hell is going on with that? Oh, very interesting. Somebody posted a photo. Right, what the hell do I want to know all this stuff for? Facebook makes a big noise just because somebody's posted a photo. Right, let's see now. So what I want is, I need a capacitor. I'm going to go for something fairly chunky. Let me look at my PCB again, because which one's chunky? I want to look at the 3D model. One of these is chunkier than the other. I need a chunky-ish one. Let's see, which one is it? Oh, these are all small. These electrolytics are all tiny. We can't thread tracks through the gaps, you see. I'm looking for something a bit bigger. Alright, we'll go back to the schematic. Let's just add a component. There should be something in Design Spark in here. Capacitor, I think it's that one. No, it's not that one. That one, that's a pretty chunky one. So I want a 100 microfarad one. So let's just grab that. Right, okay, I've got that. Right, so we want to use a resistor. Let's grab one of these little resistors, copy it, and let's see, I want something like a 10k probably, yeah. I'll grab that 10k. I'll paste a copy of that. Oh, we want to supply it from, no, actually we supply it from the main rail for now. So I'm just going to rotate that. So I'll stick it over here. I'm going to rotate that so it's tidy. So this is going to be supplying the main rail. This is going to supply the BC109C, but there's going to be a capacitor on there. So let's just so we've got our starter BC109C. Oh, another problem. Because we're triggering this by the AC. We need the other ground rail. Oh God, yeah, more problems. Let's just cross that bridge when I come to it. I mean, I can comment up the ground, DC ground, and the AC ground. I suppose it won't make much difference. Yeah, that should work. Because because this part of the circuit is going to be disabled once it starts running, so it's not really going to be in effect once the main system's running. So this is only temporary. This ground, the ground that's going to be on this BC109C is really I don't know. Right, anyway, I'll get my capacitor. Rotate that. Which is positive on here? I can't remember now. I can't remember which is positive on these symbols. I tell you, I should be looking at my chart. I'll put it away. Oh, I think that's the ground. This end. Let's check. It's pin 1. Oh, that's positive. What the hell? It's backwards. Oh no, it's a cross. Hang on, positive. What's that one? That's a cross as well. Oh, what the hell is going on here? Oh, it just says the shape's a cross. Ah, I see. So it's not a positive symbol. It's just a cross. Yeah. That's pin B. Right. Okay. Well, I'm pretty sure this bottom end's ground. I'll rotate that. Actually, the standard 100 microfarad value is not far off what I want, really. Yeah, I think that will work. So basically, actually, it wants to be down here somewhere. Somewhere. I want that capacitor somewhere like that. And now this text is in the wrong place. Do I need to move anything around? I think I'll be alright. Okay, so the BC109 has to be connected to ground. So where's our ground? It's down there. So I know what I can do to make this less messy. I want a ground, a 0 volt, so I'll bring a 0 volt tab in here. So this is basically, I'm going to change this net to 0 volt. Change net to 0 volt. Right. So that's 0 volt now, which is what we want. And this is 0 volt. Right, that's ground. Then I don't have to run tracks all over the place. I mean, circuit. Yeah, it just makes it life a lot easier. So I can just basically take this capacitor lead. And oh, where's my plus on there? Can't see the plus. Where is it? Oh, there you are. Right, well, no ball. Right, so that's, yeah, it just makes life so much easier when you can put these little tags into the circuit diagram. And why has it got 2 no bolts on it anyway? It's just silly that. I don't know why it got 2 on there. I need to shut up. I can't shut up because I think I've done something wrong here. Well, we're now driving a PMP from BT109. That's not a good way of doing it. Move that. Dear me. I need a collector to base. Alright, this has to come out. So I need to use the capacitor on the base instead. Ah dear, what more headaches, more headaches. Take that out a minute. So what I need to do is, this has got to be connected to ground. So that's right, that's correct. And we're going to use the collector to basically pull and turn on the Q3, which is there. And right, okay. So we need another tank here. The opto isolator, this trigger circuit is normally turning that on, you see. But so I'll stick this like that. Right. And when the collector, when this transistor comes on, it will turn on this Q3 as a soft starter without interfering with the latching circuit, which is down here. I don't want to interfere with that at all. Ah. Well, that's good so far. So the biasing, what we do is subtract the biasing on BC109. Oh shit, that won't work. No, that won't work. I might end up using another PMP. You see, the reason it won't work is because if we remove the biasing, oh, hang on a minute. Oh, yes, it will work. Yes, it will work. I think it will work because the signals will be arriving at both this section and this section at the same time. So basically, I was thinking that the voltage from the coil, the trigger coil, would be so great that it would still turn this transistor on. But if it's actually going to be subtracting that voltage from the base of the BC109 at the same time, it won't turn it on, which means it'll still be redundantly out of commission at that point. Yeah, so it might still work. I don't like gambling on the fact that it might work, it might not work, so I'm just going to have to think about this a bit. Oh, what I can do is probably put a capacitor on the base to emitter just to create a fraction of a delay so that it ensures it doesn't turn on when the other circuit's running. Yeah, could do that. Well, let me just wire it up and see, and I'll figure it out. Usually when I've got it diagrammed in front of me, I can work it out as to whether or not it'll work or not. I'm trying to tidy it up a bit so I can see better. I need another one of these because I've got to come on this ground over here. I lost my nut bolt. That's it. So highlight the nut bolt net. That's good, that's all not about over there as well. I'm just going to save this where I am at the moment. Probably need to clear that. I haven't changed this yet, so I'm just going to close that out. I need to clear that copper on there actually, because at some point it's going to get redone. I'm not forwarding changes yet. So I've got my naught volt command. I need it has to be done like that in order to send signals to this transistor to trigger it. Otherwise, there won't be a circuit between the pulse signal from the trigger coil to that transistor. It won't trigger because it won't have a common ground. That's the problem. So I had to join those grounds, but at least the AC ground on this side is on this other side of a resistor, so that's going to help. I'm just going to have a think for a bit. Yeah, I'm going to put kettle on. Oh my god, I'm drinking almond milk in my coffee. I've never had almond milk in my coffee before because they've sold out of cow's milk. I'll be spoiling some eggs as well. Oh, I'm just stressed out. I don't know. Anyway, I'm trying to figure out how to do this with this AC coupling soft starter circuit section. So the soft starter is basically this section here, which I'm working on. Somebody email me. Right, so I'll just get rid of that a minute because it's blocking my view. Right, so anyway, so basically I've had to couple a 0 volt with a negative ground. Sorry, the AC ground, with the negative, the 0 volts. And yeah, what I'm trying to work out is the best way of basically switching off this soft starter circuit once it starts to run. Once the main circuit kicks into effect, and I don't want interference between the two. So I'm looking at ways of basically switching off this BC109 transistor once the other system is in operation. Now, one way to do that is to simply use the opto-isolator circuit, which has got this R1 1K resistor on it, which basically takes supply voltage down into this latching system down here. So one way would be to simply use that transistor to subtract voltage and prevent the BC109 from actually working. But the problem with that is that it's not going to subtract enough of the voltage because it's floating. It's a floating. It's basically, well, it's going down through a transistor, so there's going to be a 0.7 volt gap voltage drop across that transistor, the opto-isolator there. So there's going to be 0.7 volts across there, and then there's going to be 0.7 volts across this BC547 down here. So we're going to have about 1.4 volts basically up here on this section, which is still going to bias this transistor on. So that's not going to work. Yeah, you see what I'm trying to figure out. So that's not going to work because as long as the voltage is higher than 0.7 or 0.6 of a volt on the gate, on the base of this transistor, it's still going to be able to. It's still going to be possible for that transistor to turn on when the main circuit's running, and I don't want this one to be running at all after that point. So yeah, I'm just thinking about it and trying to figure out what I can do that would basically disable that transistor once it gets to once the system's running, basically. So I'm thinking, and my brain's hurting. And I'm trying to keep it as simple as possible. I don't want to start investing in opto-isolator. Oh shit, what about? I'm a silly Billy. I've just realised something. All I need is another opto-isolator. Of course. Yeah, if I use a third opto-isolator, right? A third opto-isolator. Oh, hang on a minute. Just a minute. Am I getting ahead of myself? No, that won't work. No, that won't work either because of the voltage drop again. Because it. Well, it looks like I'm going to have to go with a PMP. Instead of a BT109, because if a PMP would it'd be a lot easier to shut it off, because the greater voltage that's building up on the AC signal outside of it, this section coming in, the AC pulses coming down. Oh dear, I've got a headache. I'm trying to think how to do this. So I've got signals coming in. I haven't actually put a coupling on there yet, so I need I need a smaller capacitor. Just a minute. So I've got the let's see. So these are small ones. So let me just see. I want a small capacitor anyway. So I want to see another. I get a couple of them C4s wherever they are. CT. Oh, that's on it. Where is it? That one. Copy that one. Right, so I've got coupling. Let's stick it over here actually. So I've got coupling coming in, and let me just, where can I put, oops, let's see, this is a soft start part, so it has to work straight away really. So I need just rotate that. I need another resistor again. I thought, oh my god, my board's going to get bigger. Holy crap. Let's see. Well, I cannot get out to here because it has to be connected to there. So this basically is the signal coming in to the BC109, and this is the bias. Actually, that resistor is going to need to be just a minute. Oops, go away. that wants to be 470k or something. 470 for gain, 470k, something like that. Probably 680 would work with the BC109. Could go higher than that even, 1 meg even, but I don't want to gain too high. Well, I'm just going to draw this in so I can see what I'm looking at, and then I can work it out easier. But basically we have a very weak signal coming in, and this BC109 serves as a temporary trigger system until the main system takes over. The question is how to disable that once the main system comes into effect. Now, at the moment, oh, hang on a minute, I've just realised something. Oh, hang on, can I? Oh, if I use an opto-isolator that when this main system was active and I've got voltage going through it, it's basically turning on these transistors. Oh yeah, can I use these transistors to turn off the other one? That's a point. Can I use the main system, the flip-flop circuit? Oh, stop it! Keeps jumping. Can I use Q1 to disable BC109C? Actually, I could. I think I can. Maybe. Yeah, I think I can actually. If I... Oh, that's a point. I am so glad I just drew all that shit in there, because now I can actually see something. Sorry about my language, I'm just getting so annoyed with this. So this is on a high gain system, so basically this will be active temporarily and it will be momentary, so it won't be timed or anything, it will just be a kickstarter, a soft starter. So it will basically drive the system temporarily, get it up to speed, and then the main system will kick in as the voltage starts to increase to drive the LEDs on the opto-isolator circuit. But all I need to do once I get it up to speed is to basically ground this. Oh, I need another resistor in here actually, otherwise I'll short out everything. So I want God, this is getting complicated. So I'll take that out. I need a resistor there. So 10k, the pulses are coming in through this capacitor, through this 10k, turning the soft starter on, and then when the main circuit kicks into effect, then we simply pull down the base. Yeah, we should be able to do that with the, let me see. Because there'll only be 0.7 volt between ground on Q1. There's only a 0.7 volt voltage drop across there, so that should, in theory, be able to pull down and turn off BC109. That should work. And I'm going to draw the circuit in, add connection between yeah, make that one there. Right, so that should, in theory, work. Because that transistor won't be on. There will be no voltage on this system, on this switch. This latching circuit here will not have a voltage on it until the main system, these opto-isolators, come into effect and start pushing power through here, and then there's going to be a voltage coming through, positive on this side basically turns the system off. Yeah. Oh, hang on a minute. So if it's positive on here, Oh no, that's not going to work. If it's positive on here, it's going to be turning on the BC109, and which means that's going to be on again. So that doesn't work. I'll take that out. Let's just go back. Oh, what have I done? Make sure my nets are still different names. Yeah, 0387. Yeah, with different names again. I went backwards. Right, so that doesn't work either. God, that milk is horrible. Ugh. I asked the guy at the shop, I said, is I can't even think what you call it now. Well, it's what I said earlier anyway. When I came back with my coffee. Yeah, that I asked him anyway if it was alright for coffee. He says, yeah. Right, well it tastes like shit. Oh god. Right, so I can't do that because when this is high, when this end is high, this track, when this is high because the system is off, that would basically make that transistor come on again when I don't want it on. The only thing that really would pull things down is this opto isolator, but then there's a bigger voltage drop between here. As I said earlier, the opto isolator, there will be a voltage drop across there, about 0.7 and 0.7 across there, so that's 1.4 volts. That voltage would still enable that transistor to come on when you don't want it on. So that doesn't work either. The only thing I could, the one thing I could do is have a floating ground. On BC109, if instead of this emitter going directly to ground, I could have a floating ground that's basically about 2-3 volts above ground, and by having that potential on the emitter slightly above ground, then the voltage drop that's across the opto isolator, and the voltage drop that's also across BC547 Q1, between that one and that one, would no longer be a problem, because you would need a much greater voltage across these two devices to be able to turn that transistor on. So yeah, okay, floating ground, I can accomplish that by simply using a Zener diode. I could just take this track out here and put emitter to a Zener diode of say 3 volts. But you see, yeah, that would work. But then I'd need a bigger pulse coming in to turn it on anyway for the soft start. I'd need at least 3 volts coming in. Actually, that won't be a problem if I'm using capacitors on this end, the pulses. I don't know, yeah. God, that milk tastes weird. I don't like it. It tastes kind of weird. Like chemical. Well, it's only till tomorrow anyway. I'll get some proper milk tomorrow. It doesn't taste like milk at all. I haven't even got a pull down resistor on here. Let's see. Actually, yeah, I need a pull down on there. Yeah, I'm just thinking, and trying to figure out a solution. This is why I usually don't live stream when I'm doing this kind of stuff, because it can take me hours to work something out, and then everyone else is just bored. There is a way I'll figure it out, just I haven't figured it out yet. So I'm probably going to have to go with a PMP system. What I like about the PMP is because the emitter is normally connected to the supply. The positive signals coming in from the main generator coils, the greater that the voltages get from the coil, we could use a diode. So the greater the voltage coming in, the greater the positive voltage, the more it would turn off the PMP, which is the other way around, which is the way we want it. We want it to turn off the transistor as the main system comes into effect. So using a PMP is probably the way I need to go. I use a bunch of signal diodes like 1N914s, simple 1N914 transistor diodes that would send voltage to the transistor and basically turn the gate off and have that capacitor there that would ensure it stayed off in between cycles. So that the pull down resistor, instead of going to ground, it would basically go to supply. We would simply have another resistor that was of a value that would sustain that voltage across the PMP, for a few minutes or a few seconds anyway, long enough to keep it turned off until the system basically was shut down, and it would discharge, then it would be enabled again. So that's possibly what I'm going to have to do. But the reason I was going to use a PC109 is because it's got high gain, and I don't really have any high gain PMPs kicking about. I don't suppose it matters too much. I don't suppose I need that much of a gain. It's not exactly a microphone. So I don't know what I'm thinking really. So let's go to let's use another BC557, which is the Q3. Let's basically get rid of this. Right, I'm just going to start from scratch. Let's just disconnect this lot here, because it's all going to be wired up differently anyway. Disconnect that one. Right, we just want this input signal coming in. Right, let's get another PMP. Right. So if we use another BC557, the footprint's pretty generic, so if I find another high gain PMP, I can just swap it around as long as the base is in the middle. Right, so obviously driving a PMP with a PMP is going to be a problem with the way I want to do this, but so I'm just thinking about something like that then. unless it was cascaded, that's no good. Oh, actually that would work. Oh, a minute. So if I brought this down here, oh, I don't have to bring it down here. Actually, I'll just connect. Ah, stop it! Go away. Right. So if I put the emitter, this will give me gain as well. Right. So if that emitter is on that PNP, and we use our resistor, I want 0 volt on here, you dumbass. Change net. It keeps jumping to a different net. Somebody email me. No. As usual, don't get no fan mail even at Christmas. Everybody's dead. Who needs Home Alone? Right. So as the circuit becomes more, oh yeah, except that this is going to be triggered by a negative pulse though, instead of a positive pulse. Oh shit, another problem. This is just getting beyond belief complicated. Would that matter? Let me think. No, actually that doesn't matter, because it doesn't matter if this start circuit is triggered by a negative pulse, because once the system starts up, oh actually it might do. No it won't. I don't think it will. Let me think about this. Magnets coming in. Because the starter circuit is simply one. It's not. It's not an on latch and an off latch. The starter circuit is simply a pulse. It's simply a soft start pulse. So it basically is a short pulse duration, and it goes off. So I'm thinking about it. I think it will still be okay, because once the other system kicks in, the main system, it will be driven by the positive pulses, which is a latching system. So I don't think there's going to be a problem with that. I think I'll just draw it up anyway, and then work it out later, and then because this is a supplementary addition I'm putting on the board anyway. I can always disable. I don't have to build that on straight away. I mean, I might come up with a better idea in the meantime anyway, so I might as well just draw it up for now. Right, so let's just go with it for now. A negative pulse as a soft start. Because it's only going to be engaged for 5-6 seconds, well, until it gets up to speed, and then the main system will kick in. And actually there's an advantage with that being a negative pulse as well, because the main system will be a positive pulse, so the positive pulse would negate the negative pulse. So yeah, that might work still. So we stick our 470k. And not forgetting our capacitor we want, which will basically store positive charge to disable that transistor once it's running. Right. So that would basically charge up. That 470 wants to be lower though. Let's see. I think it needs to be put a 1k in for now. That's a bit too low. This one. What was it? Is it 10k that we were using for biasing? We want something higher than that, otherwise it's going to be odd all the time. I'll go back. I think the 470 was probably still okay. Put it back to 470. Normally this end is low. This wants to be lower. 4 point, I think 4k7. wants to be quite low, that value there. It's going to be across that capacitor. So we connect that to there, which will basically create a higher positive potential to pull down the have I got this right? Yeah, because if this the more positive we have on here, the more it turns itself off. Because PMPs are back to front. Let's see. So we can charge this capacitor up simply by the main system once it kicks in. We've got DC voltages coming through this LED, and we'll have a diode like that. Just charge up this capacitor. So let's copy that now. Let's see. Paste it over here somewhere. This bloody diode so freaking big. Let's stick it down here somewhere. Everything's so cluttered here. It's getting really bad. I know. How did that get over there? Don't know. Right, so this diode would get charged through our LED basically. Stop it, I want a line. So if we put that to there, so as the LED comes on, there's voltage coming through there. Because the reason I'm using the LED is because it's also rectified, so we're not going to get a negative pulse on this end of the LED. It's going to be just, the junction here is basically positive. Now I've got a diode across these to the LED and the opto isolator internal LED, and basically this diode here is to create an AC loop so that the AC can travel backwards and forwards. Well, I don't want that AC loop to be translated into this circuit over here, so I need to just tap off the DC side here, which is why I'm going to use the other side of this LED, which is only a few milliamps, which is all we really want. Enough to shut off that transistor, so it will basically come out, go through this diode D3 and charge up that capacitor, keeping that PMP turned off basically. That's what the idea is. So let's just try that, connect that to that. So I'll zoom in a bit so you can see what I'm doing. So yeah, so by using the LED as a rectifier, where's it gone? Right, so as you can see, there's LED, then the opto isolator built-in chip, microchip LED, the infrared LED, it's built in. So we can tap off between that main onboard LED, which is that. Oh, I haven't got my 3D model up, which is basically that here, this green thing here. So this is where this is. So I'm going to tap off some voltage and shunt that off to charge up that capacitor to keep that when this main circuit's running, it will basically keep a higher positive bias on Q4, which will effectively turn it off. That's the idea. But will it turn it off? Because obviously my resistor, my 470k, is probably too high, so I probably need to bring that down. I don't know. If I go too low, it's going to turn on automatically, even when it's not. This capacitor is not charged, because this is going to be low to begin with. So this end's going to be quite low. I'm probably going to have to. I don't know if I can breadboard this section here just alone, because I don't think I can really, because I need the coils and everything to do all this. So testing it's going to be a pain in the butt. It really is. What the hell's happened to my bloody Discord? It's just logged me out. What? I don't believe you. Oh, for God's sake. Freaking want to log me out for? I'm on my phone, it's just driving me up the wall. Oh, hang on a minute. I'll be back in this sec. I'm just, private stuff, you know. So yeah, this is all logic-based nonsense that I hate doing, but you've got to work it out, and the highs and the lows, literally. So until the main system's working, this voltage on this section here, on this particular area, is going to be non-existent until the main generator, the coils start generating some energy. So this particular part of the circuit, it's going to receive some very weak pulses coming through that aren't strong enough for it to pass through the LED. So the signal basically comes through, goes through a capacitor, through a resistor, and switches on this high gain situation transistor that will give us a soft start pulse to our Q3, which basically will get the ball rolling, as they say. So as the voltage is pulsing through and it's giving us a soft start mode, everything will appear to work normally, and the voltages will start to increase across the potentiometer. Voltages will start to emerge on the other side of this LED. voltage will start to pass back through the system, through this diode, and this capacitor will slowly start to charge up, and as it charges up we'll get more negative bias on Q4. And I'm just going for the logic part of it. So the circuit will continue to grow exponentially with voltages through this, and the opto-isolator will kick in. It will start to do the work and start to switch our latching circuit, which is down here somewhere. So our latching circuit will start to work. The voltages will get much greater on this C5. C5 will charge up with a voltage that will cancel out, basically bias the Q4 off so that it's no longer working. But there are still signals coming through, and the signals are getting bigger and bigger and bigger on C6 and R12 and through this 10k resistor, trying hard to turn this transistor on. So we're still going to get voltages coming through here that will basically be trying to turn on this transistor here. So what I need to do is put a bit of reinforcement somewhere so that the greater the voltage is coming through here trying to turn this bugger on, the more we have something to basically pull that back down again. So yeah, there's more work needs to be done. So when we have right, okay, so what I can do is I can use a Zener diode or something, so that as the voltages start to get higher and higher and higher, or just a diode, or two diodes. Okay, right, so let's say that our initial pulses are very weak. They're about 0.7 of a volt, so it can trigger this transistor on. The soft starter will work. We have a simple situation where there's a diode like this. So let's copy that again. So 1N914s, let's imagine. So first put this here, as Shangu likes to say. Let's see, put that diode there, and we will basically be sending a small pulse to turn this transistor. Actually, it's a negative pulse. I've got it the wrong way around. Right. So we want a negative pulse. So I'll just disconnect this from here. Right, and I'm going to connect to this diode and this diode. I'm going to come all the way down here. Right, so we have a pulse, a weak pulse going through this diode that's pulsing on this Q4 to turn it on briefly to trigger it, and it's been biased by this 470k. Now it's getting negative pulses to turn it on. As the voltage is increasing on this side, we need to create a situation where the voltage on this base of this transistor starts to be saturated with more positive voltage, so that it will no longer turn on once the main system's running. So what do I need? I need to reinforce that positive voltage that's coming from the generator as it increases. So what do we do? Well, we could have a diode or two ordinary diodes in series to reinforce the positive. Just 1N914s. And because we have two of them, we have a bigger voltage drop across them. So that increased voltage from this AC signal that's coming through, we will get more positive. As the voltage gets beyond let's just work this out. Hang on. Calculator. 0.7 times 2 is 1.4 volts, is what I was saying earlier. 1.4 volts, right? So basically what will happen is once we get beyond 0.7, 0.8 volts negative, to turn on this Q4, Q4 will basically perform the soft starter function, which will turn on this output to trigger the MOSFET to start to do the soft starting. And we don't want too much voltage coming into the system because we don't want to oversaturate this transistor, and we also don't want to we don't want any false triggering once the main system's working. So what will happen is, because we're using one diode here which on a negative pulse through this resistor and this capacitor, will actually drive that quite happily, and so we can basically do away with this resistor down here somewhere in a minute. This one, we could do away with this now because I don't think we need that. Do I need that? No, I don't think I do. So let me just delete that. We don't need that. Because what's happening now is this capacitor here is going to get charged through these diodes, because there's going to be more positive. Once this system on this side, once the trigger coils are generating enough positive voltage to jump this diode and this diode more than 1.4 volts, we're going to get higher and higher and higher positive voltage coming through this side, which won't damage the PNP because it's triggered by a negative voltage. And as this voltage increases on the base of the BC557, there'll be even less chance that it's going to get turned on, because of the biasing is going to be more and more positive. So this capacitor here down here is going to have a much higher positive potential than negative potential, because it's going to get fully charged up by these two diodes, because there's going to be more than 1.4 volts coming through at that point. So this transistor is going to basically be totally turned off, which is what I want, because this system down here is going to be doing all the work. I think that would work. I'm just going to rotate all this one because it's all messy. Right, so I think that would, 3 diodes is probably all I need to prevent that transistor from continually functioning when we don't want it to do, because the positive part of the cycle is going to come in and basically increase the negative bias, really, the negative biasing on it to make sure it doesn't come on, because really all we're getting is a small negative signal coming through here, which isn't going to be sufficient based on the amount of positive. There's going to be great, because there's 2 diodes there. We're going to have a much higher voltage coming through here than we do negative, I'm thinking. Or have I completely got this all wrong? I don't know. I certainly don't want to interfere with this section down here, because this is part of the main system. This and that is part of the main system, and we're just basically tagging onto it on here to trigger it prematurely in the soft start. So the soft start triggers it temporarily. Just making sure everything's working. I mean, the 1N914s, they don't take up a lot of room. The only additional components I've got really is one transistor and a few extra resistors, 2 capacitors. There's actually quite a bit there. Yeah, I'm going to have to make my board a bit bigger anyway. I mean, this circuit board is it's going to be too small. I don't want to make it. Let's just bring it down here a bit. This is my board size. I'm going to bring it down here because I'm going to have to make this board bigger. When I forward everything, I'm not going to forward anything yet because I'm going to have to unroot all this lot and move things around. It's going to be a bloody nightmare. So where's my Q3? Oh, here. Where's Q3? That's Q1. I'm blind, I can't even see it. Oh, it's up here. The label's hidden from me. Oh, that's Q2. Oh, of course, I added Q3, didn't I? Yeah. That's why. Yeah, Q3 will be basically Q3 will basically be connected to Q1. So Q1 is there. So yeah, I'll better put that extra bit of circuitry down here. I'll be able to run it all around here, this section. I've just made it a bit bigger so I can add all the extra components on here. So this is Q1, so I'll have to unroot some of this stuff so I can get this all fitted in down at the bottom. I'll have to move my header to plug socket. I'm going to have to move that so that it's in down here somewhere, because that's the output socket. Right. So I think that will probably work actually, because the diodes will act as a clamp as well. It prevent the voltage from going too completely out of control high, because all we want is a tiny little voltage, really, a 0.7 well, up to probably less than a volt anyway, just to turn on this transistor, the Q4, which will be soft starting Q3. And once our voltage gets higher than that, we don't want any clipping. We don't want any problems with that, so by having these diodes like this, we'll end up with a higher voltage on this side than a lower voltage, and yeah, that's what I'm thinking anyway. So it should prevent the system from blowing up anyway. I mean, as in, it should prevent us, because we've got a 10k and a 10k resistor there that's in series that's going to be biasing this transistor, and that 10k is not going to have much of a chance of turning this transistor on if this voltage on this side is just way up, you know, because this voltage, don't forget, the voltage drop between this resistor here, 470 ohms, right, this 1k, right, and then goes through this to the emitter of the PMP. So there's going to be a voltage drop down here as well. So the emitter at this end, so let's say the main power rail is 12 volts, right? The main power rail is 12 volts, right? So we're going to have probably 10 volts on the emitter, something like that. So there's going to be something like a 2 volt drop, especially when this main circuit's operating. It's going to be pulling it down all the time as it's sending power out to this circuit. And so this end, this part, I could probably stick an anchor capacitor at this point as well to stabilise everything. Like I stick an extra electrolytic between this junction of R5 and R9 to ground, which will basically be like a floating voltage. So it will be anchored at, say, around 10 volts. It will hover at that point. It won't be jumping up and down like a blooming seesaw all the time. So that will prevent me from having false triggering on from Q4. Oh, my eggs. Oh, just remembered. I was hard boiling some eggs and I completely forgot about them. I hope they're alright. They should be alright. They're hard boiled anyway, so. I just hate it when they go black because you boil them too long. How long have I been talking anyway? My God. Oh, I think my eggs are going to be like rubber. I forget everything. I'm thinking so much I forget everything. Alright, anyway, at least I've turned them off now. How long have I been live streaming? An hour and 45 minutes. Oh my God, have I been hard boiling my eggs for about an hour? That's probably what I've been doing. Oh my God, my hard boiled eggs are going to be like rubber. They really are. Oh, that's a disaster. Oh well, we'll find out. At least they'll be free of bacteria. Oops. I'm going to have to crack one open and just check it because I'm worrying about it now. I actually boiled five eggs as well. I hope they're alright. yum yum, they're fine. My eggs, my hard-boiled eggs have come out perfectly, so that's a relief. Right, so where was I? Well, I suppose I could build part of this onto a breadboard and use my signal generator. Put my signal generator through these two diodes and this diode and to the PMP, and use a capacitor and everything, and I could test the basic function of that, I suppose. Oh, that egg's giving me bloody burps now. So this is getting more and more complicated. I'm going to forward the changes and see what it looks like. Let me just unroot some, I don't know if I should unroot all this lot. No, I'll just forward the changes first and see what happens. This is going to be a little bit, oh my god. I've got another rat's nest to deal with. Yeah, so that one's come down here. Come here. That's not going to be so bad. So that wants to be on the other side. Our head won't flipping. That resistor's now in the wrong place, so let me see. Actually I'll move my head up. Let's see if I can put that. No, that, cross that bridge when I come to it. That was just got to be up there because it's connected to this slot up here, so yeah. Oh, what I can do is I can flip this around. Flip that around. flip that, oops, rotate that around, and that would have to be, it's going to move all this all up here. Still not right. Ah, it's crossed again. I want it to be like that, and then go away. Yeah. Yeah, I can route that track all the way around. I'll leave a gap. So I have to move things around a bit. R13 isn't connected to anything at the moment, so it's a lonesome guy. Don't even know if I need that now, I don't know. Anyway, I'm just wanting to get things reasonably sorted out on here, because rat's nest can get daunting. The more components you start to add, the more of a nightmare it is to sort it all out. So I wanted to get something organised so that this thing here wants to be connected. I'll auto route that. I changed some of these things to power, you see, so they've got thicker tracks by default now. That header's going to be, oh yeah, that's going to have to go. Because this AC wasn't connected to that ground before, but it is now. So The way to sort that out, I suppose, is flip my header around. So what I need to do is unroot this lot here. Unroot that lot there. And this header wants to be spun around. And now I could just auto route that. Auto route that. Oh no, not down there! Bloody hell, that's a mess. Net 0297. That's not a vault, so where's not a vault? Not a vault. Alright, I'll go. Oh shit, the track's massive. Hang on a minute. Track what is it? Style, track style. I'll go to min a minute. And I want to be on. Do it. Right, optimize nets. Right, I'll thicken that up in a bit. I just don't want it to be too massive. Net 0297. Net 0297. Auto route that. This is crossed over to that one now. Oh, that's connected to there. So, oh, that's no. Oh. So I just have to go around. Oh, another massive track. Optimize net. So I need to go into my settings. To that. Just want to get this top end sorted out. I can work out this bottom end later. I mean, okay, I haven't finished the circuit diagram yet. There's more work to do on it, but I need to see how this is going to lay out, because every time I make a change, all these rat's nets just get worse and worse, and I need to get some organisation in there so that it doesn't get too daunting, you know. And I look at it and go, oh no, I'm not going to do all that. You know, it gets like that if you leave it too long. What a 3D model looks like, it'll be a mess. Oh, let's see. Actually, it's not looking too bad. Just a lot of stuff isn't connected yet. That capacitor is on the edge of the board, but I'll sort that out in a bit. I've got to move everything around. This isn't too bad, really. the transistor could possibly go over here. This can't. Let me just see about this. Actually, it wants rotating. Yeah. So if I move the header can be anywhere. It's just a socket, you know, I can plug into it. Let's see what it was like down here. Q3. I need to move that up a bit though, because I heard it thinks I'm double clicking. I'm not. Right, so if I just join that to that, that's better. Put that header there. So that track is just a bit too thick for my liking, so I'm going to go back to, yeah. Yeah, let's see, what about that one now? I'll do that one. Oh yeah, I forgot, yesterday I discovered that you can highlight multiple tracks and change them all at once, so I probably should be doing that later. I'll just auto route that one. Undo that auto route, because I've just realised something. I want to move that. Gotta move everything up a bit. That's better. I've got a cross connection here. I'm not sure how I'm going to deal with that. This capacitor could be moved. Or can I move that that's connected to it? Yeah, I can. So if I stick this resistor down here and this capacitor down here, keep coming back like a bad dream. Right, so move this up here. Yeah, that's better. Look, no cross connection now that I can see. Stick that down. I'll rotate that. Oops, too far. Stick that down there. Right, so now we can auto route this. It's still too bloody big. I'll sort it out in a bit. So we've got that. That's the main ground. That's 0 volt. You see, this big thick track is 0 volt basically. We'll bring these two together so that they don't get caught. Get these two linked up. Auto route those. Get that routed. Get that routed. Well, what's happened here? What's going on with this one? That's it. Auto route that one. Auto route that one. Auto route that one. Now we'll cut this off, you see. So these need to go outside, so we can go through that capacitor there. Oh, well, we have to go through that capacitor there. It's the only way through. So these want to go through between this capacitor. So what we have to do is auto route that. See if it can make it through by itself. No, it can't, because this one's moving down a bit. Try it again. There we go. It's not very tidy. It's not very tidy, but I can tidy it up a bit. That's not so bad. That's a big capacitor though, so the track can go through that. I can make it thicker than that, but auto route that. I like clicking the auto route, it's fun. Saves me having to draw them all manually. Right, so have we got it all connected? Let me just see. Tools, design rule check. Number, one error. Oh, that's not bad. Only one error? Where is it? Right, go to error. Where is it? Oh, it's that flickering resistance outside the box, I bet you. Oh well, we don't have to worry about that. Oh, let me just run it again. Dangling track. Oh, it's a dangling track. Where? Can't see it. Dangling tracks are really nothing to worry about. They're just little pieces of copper or transfer or whatever that basically don't go anywhere, but they're often still connected to something. But I'm not really worried about them. But oh, it'll probably be up here somewhere. Anyway, I'm not going to worry about it for now. Just saving everything. Right, let's refresh this. Oh, it looks better, doesn't it? I've got thin tracks down there, but I'll sort that out later. Anyway, I'm not happy with the circuit diagram yet, so I'm not too worried what it looks like right now, really. But it's just nice to be able to see what it looks like, you know, even if you don't even know if it works yet. Well, most of it will work, but it's that a soft starter thing. It might not work properly, so I need to sort that out. And that's basically all this section down here. God, all them components just did. Yeah. So that resistor that's not connected to anything, where is it? It's up here somewhere. Oh, there it is, R13. I'll just delete that. Always copy another one if I want one. It's just forward design changes. That resistor will disappear then. Yeah, it's gone. Right, so yeah, I need to. I'm going to have to take a bathroom break. But I'll tell you what I'll do. I'm going to end the stream for God knows how long. I'm going to have a little break. I'm going to do some more coffee. I'm going to get some coffee and see if I can find something better than that crappy oil milk. Ugh. Yeah, and yeah. And I'm going to think a bit more about this section here that's so I'll put a box around it. Well, this section here is really what I'm not sure about at the moment. Obviously the input signal, that's pretty standard, that's what we need. The output section, well, it goes to this, we need that, but finding a way to disable this properly using just the diodes, I don't know. I'll have to determine that. That's something I need to test out. I'm probably going to have to build part of this onto a breadboard, just this section on a breadboard, and inject an AC signal. And I've got a frequency generator on a frequency, digital frequency readout coming as a Christmas present soon, which I'm going to fit it in my signal generator box, because I have this meter in my signal generator box I was showing you previously, and the meter doesn't really do a lot. It doesn't really do anything actually, and it was really there to show again a volume level, and I'm thinking about just taking that out and fitting a digital readout on there, which would be far more useful. I mean, I built that thing back in the 80s, so I mean it's never got finished properly. So if I could just build this digital readout into the box, then when I'm turning up my frequency dials and adjusting the frequency output, I can actually see what frequency I'm generating, instead of having to stick a meter on it or an oscilloscope on it to see what it is. It will be useful to actually be able to see what it's actually doing. So that's something I've got. And that's another project that's coming up for my frequency generator unit. But that's for a rainy day. I'm not in a desperate hurry to put it in there. I could use it freestanding just temporarily, but I really want to finish that box though, because I started it in the 80s and I never really completed it, and it generates both audio frequencies from, actually it does work from 10 hertz. It goes from 10 hertz. When you're running it on the right voltage, it runs down to 10 hertz. It starts at 10 hertz, it goes up to something like 20-30 kilohertz or something. And then there's another oscillator section in it, which is RF, and that goes between basically from the bottom end of the maximum audio frequency band into up to about 1 megahertz or something. I can't remember exactly, but that's the reason why I need to put a signal readout, a frequency generator, a frequency meter on it, so I can basically see what it's doing. Anyway, I'm going to disappear. I'll be probably back later, I don't know. I'm going to spend a few hours thinking about this. That's what it is. I need to think about this and decide where to go next, really, as regards improving the trigger off thing. So that's really what I need to do, is have a think. Alright, toodaloo, bye for now. See you later.